Hi, I'm Ben Pearson, the Roadster Tracker, and today I want to talk to you guys about something that has been in the news pretty recently. Elon Musk is well known for making his bold statements, but perhaps one of the more controversial ones that he's made recently is in regard to the planet Mars. See, Elon Musk wants to nuke Mars. Would this actually work? Is this something that could realistically do anything? Well, let's start diving into this and see what we come up with. First of all, the idea behind nuking Mars is if you can nuke it, you might be able to raise the temperatures to the point where it's more Earth-like, and thus we might be able to do something interesting with it, like, say, live on it without a dome. Well, it is theoretically possible to terraform Mars, although it proves to be a lot more difficult than you would really think about. And so let's look at this one thing at a time. First of all, how much carbon dioxide is there that is available near the surface of the planet Mars? There's basically 4 areas where carbon dioxide could potentially lie within the surface of the planet Mars. The first one is carbon dioxide that is frozen on one of the poles. At the poles of Mars, it gets cold enough where carbon dioxide can freeze, and it is known to be on the northern ice cap of Mars. In fact, we know there is carbon dioxide there. The amount, though, isn't very much. It would be something like 6 millibar, not a huge amount. And in fact, most of this dry ice will actually evaporate during the northern summer. The southern cap of Mars isn't really known whether or not it has any, but we have a pretty good estimate of this, and it's not a lot. Now, there is something that's a little bit more interesting called clathrite. Clathrite is where ice will form a crystal and it will trap carbon dioxide in there. If you have, say, soda water that's carbon dioxide and you freeze it, it may trap some of that carbon dioxide in there. And we know how much ice there is on Mars, and there's actually a fair bit of ice on the surface of Mars. If you laid it all out, it'd be enough to cover the surface with quite a bit of water. And most of this is trapped in the ice caps that are found near the top and bottom of the planet. Now, if all of this ice could trap carbon dioxide, it's possible that there could be 15 hundredths of a bar of ice, 150 millibars, which is actually quite a bit. For reference, 1 bar is approximately the atmospheric pressure here on Earth. So that would be a substantial amount and would be enough to raise the temperature of Mars fairly significantly if it does in fact exist. However, this is the upper limit, and in order to have the upper limit, you have to have a fairly high pressure carbon dioxide environment. The soda water example that I mentioned earlier, if you freeze the soda water, then you're probably going to do fairly good in terms of getting this there. But if you just have a little bit of carbon dioxide, then you're not going to trap a whole lot of it in there, and so it's likely that there's much, much less than this. So the other 2 sources are basically found in the rocks. Some of the rocks can actually absorb a little bit of carbon dioxide, and also some of them will release carbon dioxide when they're heated. Now, it's thought that if you take all of these sources of carbon dioxide and put them together, you're going to be about 60 millibar of an atmosphere if you could release all of them. How much would that really affect the temperature of Mars? Well, it would raise it by about 10 degrees Kelvin. That isn't a lot. 10 degrees Kelvin is just not nearly enough. In order to make Mars Earth-like, you'd have to raise the temperature by about 70 degrees Kelvin. That would take roughly the pressure of the entire Earth's atmosphere to happen on Mars with just pure carbon dioxide. Now, if you had that much carbon dioxide, you're going to have another problem. You're not going to have any oxygen, and quite frankly, a pure carbon dioxide environment would be completely toxic. It would not work. We could not live without a dome, and there's no amount of pressure where you keep that much carbon dioxide in the atmosphere where you can maintain pressure. Also, this carbon dioxide would eventually leave, and it just is not really realistic. Okay, let's just set aside reality and say hypothetically that this carbon dioxide was possible. Would a nuclear bomb actually release all of this? Well, There's two different methods that are talked about. First of all is just using the nuclear weapon to detonate the ice. We know how much energy it takes to sublimate carbon dioxide. Sublimate is when you change directly from a solid to a gas. And this is 571 joules per gram. How much carbon dioxide would it take to have 1 atmosphere pressure of pure carbon dioxide? It is an astoundingly large number. It's 144 trillion tons of carbon dioxide. Just an amazingly large number. You can take this out and you can find the energy. Now, joules is a relatively easy to work with unit, but when you're talking nuclear weapons, they like to use the unit of energy that is tons of TNT. So how many tons of TNT would it take to sublimate that much carbon dioxide? It would take something on the order of 3.5 teratons of TNT. That is an enormous amount. Just for reference, the largest nuclear weapon that was ever detonated was named Tsar Bomba. This bomb had an enormous amount of energy, and that was 50 megatons of TNT. Far, far larger than the largest United States weapon, which was about 15 megatons. But that still pales in comparison. You would need on the order of 700,000 Tsar Bombas to be brought to Mars to be able to explode all of that carbon dioxide into gas, assuming you could even figure out how to do a perfect energy transfer, which is not going to happen, by the way. So you just can't do it. As previously mentioned, there's an accessible amount of carbon dioxide that is in the poles and other regions of Mars. And that's about 1/50th of what you would need to completely terraform Mars. It'll still raise the temperature a little bit, but not a huge amount. Okay, so could we do this with 1/50th of the energy? Well, that's roughly equivalent to the entire stockpile of both the United States and the Soviet Union during the height of the Cold War. Probably even more than that, to be honest. And that was assuming that you have a perfect transfer. That idea just is not going to work. Okay, let's take a different idea. Let's say instead of trying to just melt the ice caps, that you're trying to raise the temperature by exploding a nuclear bomb of fission. This idea was also proposed by Elon Musk. How would that work? Well, you can figure out how much sunlight there is that is coming from the sun, and how much hits at Earth, how much hits at Mars, and how much it would take. And so I'm going to assume that you want to have the amount of energy that is hitting the surface of the Earth at the upper ends of the atmosphere of Mars. You probably would want a little bit more, but let's just take this one step at a time. How many bombs would you need to make this happen? Well, if you do the math and you take the same Tsar Bomba, the largest nuclear weapon ever detonated, and it would take one of those every 15 seconds if you could get all of the energy to the surface of Mars to make this happen. Quite frankly, that just is not going to happen. Now, there are some other ideas out there on how we could terraform Mars, but the truth is this is something that is in the realm of science fiction. We don't really have the technology to do it now. Yes, it's something we might be able to do at some point in time in the future, and it's a lot of fun to talk about. But nuking Mars is not the answer. It will not make things work. Thank you guys very much for joining me. Let me know whatever questions or comments you guys have. And let me know if you think that I missed something. Until next time, keep on tracking. Take care.